Today we are going to a new unit, that is unit number 2, kinematics. Last unit we discussed about branches of physics. The physics has classified into two types. One is classical physics, the other one is modern physics. In classical physics there are 7 branches. In that, one of the branches is mechanics. This mechanics has classified into two types. One is static, the other one is dynamics. Static means study about objects which is at rest. Dynamics means study of objects which is in motion. This dynamics is classified into two types. One is kinematics, the other one is kinetics. So this kinematics, now we will be going to kinematics. So this kinematics can be split up into two forms. One is kinema, the other one is matrix. This word is a Greek word meaning motion. In Greek, the kinema meaning is motion, and matrix is nothing but mass. Okay. Now, in kinematics, what we will do is we will study about motion of an object without considering the force. Without considering the force. Without considering the force. So, we will study what? The study of motion of an object without considering the force that causes motion. That is called kinematics. In kinetics, study of motion of an object considering the force. Here we will consider the force. In kinematics, we will not consider the force. Why we are not consider the force? That is, now let us consider this is a wooden block displayed on a table. Now I want to move the wooden block to a particular distance. That means the block has been changed the position. How I can move this? With the help of force I can move. Without the help of force I can't move the object from one place to another. Clear? But in kinematics they never talk about force. Why? The term force was proposed by Newton. He proposed 3 laws. In the second law, he introduced the term force, that is F is equal to me. He introduced the term force, F is equal to me. But before Newton era, this kinematics was developed and mostly explained by Galileo. It was mostly explained by Galileo. So, in kinematics, it includes speed or velocity, distance or displacement, acceleration. So, in kinematics, at that time, it includes speed or velocity, distance or displacement, and acceleration. The term force is not included. Clear? Now, the force, the motion of the, or we can say that we know that motion has been used in all the places. That is from microscopic level to macroscopic level. So microscopic level means within the atom. Macroscopic level means planetary system. Understood? There are various types of motion. One is linear motion, circular motion, rotatory motion, oscillatory motion, or vibratory motion. The study of various types of motion can be expressed by using the language of mathematics. By using the language of mathematics. In science, we do experiments, but in physics, we do experiments, and without the help of mathematics, we can't get the result. So, we will do experiments, and without the knowledge of mathematics, we can't get the result. So, these two are, this mathematics and experiment are the two pillars for physics. Clear? So next we will go concept of rest and motion. Concept of rest and motion. Before going into concept of rest and motion, first we will define what is rest and motion. Define rest. When the object does not change the position with respect to time, then the object is said to be at rest. So, for example, I am giving a gesture here, and I just note down the time. Let it be 5 o'clock. Then, after 6 o'clock, I am watching the duster. It is in the same position. Then 7 o'clock, it is in the same position. From this, I can conclude that this duster is at rest with respect to time. Understood? Now, next one, motion. Take this duster at 5 o'clock, it is in this position. Then at 6 o'clock, it is in this position. And in 7 o'clock, it is in this position. That means what? The object is moving with respect to time. So, I can define motion when the object changes the position. When the object changes the position with respect to time, then I can say that the object is said to be in motion. Clear? Now, we will go to concept of rest and motion. Let us consider this one is jet. Inside, that is house will be there. Then there is a hall. Let us consider this one is a hall. This one is jet. So inside the hall, one table is there. Then on the table, you keep one book. You keep on book. You just stand on the floor and watch the book. At 5 o'clock, I started watching the book. The object, that is, the book, is in the same position. 6 o'clock, then 7 o'clock, 8 o'clock, like that. But there is no change in the position. Obviously, I can say that the book is at rest when with respect to earth. Now, I am standing on the moon. Now I am standing on the moon and I am watching the book. What we will observe, the book is in motion. Why? We all know that rotates. As that rotates, therefore, that is, the book is also rotates. That is, it will be in motion. So from this, you can say that the book will be at rest with respect to earth. The book will be in motion with respect to moon. Okay, so they introduced a new term. So only they introduced a new term, surroundings. They introduced a new term, surroundings. That is, in lower classes you study in time, but in 11th standard, instead of time, you will be studying surroundings. Now, we will see an example. Let us consider a car. So inside a car, we are sitting, and this car is in uniform motion. The car is in uniform motion. We are sitting inside the car. What we will see, we are at rest with respect to fellow passenger. We are at rest with respect to fellow passenger. So he is at rest with respect to fellow passenger. But outsiders. But if the person seeing from outside, what he will say, we are in motion. We are in motion with respect to what? Outsiders. So the surrounding will determine whether the object is at rest or in motion. This surrounding word has been given a new term, or we can call it as frame of reference. We can call it as frame of reference. What is frame of reference? This can be explained by coordination system. This can be explained by coordination system. Why do we need coordinate system? If you want to find out the position of an object, we need coordinate system. So I can tell coordinate system plus time will give frame of reference. What is coordinate system? This is nothing but three mutually perpendicular axes, or we can call it as coordinate system. Now you see, this is x, this one y. These two are perpendicular to each other. If you take the third one, I can't draw the third line like this because it is in two-dimensional figure. So I will be drawing the line in this direction and let it be z. these three axes are mutually perpendicular, then they are called it as coordinate system. Why we need coordinate system? To find out the position of an object, we need to know coordinate system. Now, let us consider an example. I want to find out the position of P, which is at 2, 4, 6. This 2 represents x-axis, 4 represents y-axis, and 6 represents z-axis. Now you take a plane x, y, z. Now in x-axis 2. From here it is 2. Now you draw a parallel line from x to y-axis. Understood? Now y is equal to 4. Now you draw a parallel line from y to x-axis. Draw a parallel line y to x-axis. Now these two lines intersect at a point. From this you draw a parallel line to z-axis. Understood? Now from z is equal to what? 6. From here, from z, draw a parallel line to y-axis. Now you see they will meet at one point. This will give the position of P. This P, 2, 4, 6. Clear? Now we will see an example. This I can call it as this line y coordinate. I can call it as y coordinate. This one x coordinate. This line I can call it as z coordinate. That's it. Now we will see an example. This one is the ground. Now, let us say this is a car. Inside, 2 person is sitting. Now, I am keeping frame of reference on the ground. Now I am keeping frame of reference on the ground. Now I am observing this. This car is in uniform speed. That is in motion. Now from this point of reference, the passengers who are inside will be on motion. Will be are in motion. They will be in what? Motion. Suppose if I keep the frame of reference, if I keep it on the car itself, if I place the frame of reference on the car itself, then I can see that the passengers are at rest. Clear? Now there are two coordinate systems. One is right-handed coordinate system. The other one is left-handed coordinate system. In physics, mostly we will use right-handed coordinate system. Now we will see how to find out right-handed coordinate system. Now let us consider this one is a clock. If the needle moves in this direction, then I can call it as clockwise. Suppose if the needle moves in this direction, then I can call it as anti-clockwise. Now, for finding out right-handed coordinate system, actually there are three rules. Rule number one: the fingers must get on the x-axis. Next, rotate the fingers along the y-axis. Third rule: thumb points out z-axis. So in right-handed coordinate system, if in right-handed coordinate system, if the plane rotates in anti-clockwise direction, if the plane say x, y, z, so if it rotates in anti-clockwise direction, then I can call it as right-handed coordinate system. Understood? Now, you will see z up. That means z will be upward. This one is x. Now I am going for right-handed coordinate system. Now what is the first rule? Fingers must get on the x-axis. Okay. Next, what is the second rule? Rotate the fingers. See, I am rotating it. See, I am rotating. See, the fingers are coming inside. So my y-axis will be inside. My y-axis will be inside. So, in which direction it rotates? It will be in anti-clockwise direction. This is right-handed coordinate system. And z is up. Suppose if it is left hand, where will be the y? Now, keep the left hand fingers on the x-axis. Now, second rule is what? Rotate the fingers. Now you see, rotating. I am rotating outside, coming out outside. So y will be outside. So what will be direction? It is in clockwise direction. Next we will go for y up. X, y. For right hand. This one is for left hand. For right hand, first rule is what? Keep the fingers on the x-axis. Second rule, rotate the fingers. That will bring what? Y-axis. The thumb represents outside. The thumb represents z-axis. So it will move in the anti-clockwise direction. So right-handed coordinate system for y up. Here you see x, y. Keep your left hand fingers on the x-axis. Second rule, rotate the fingers. See, z-axis here. Rotate the fingers. I am giving this, rotating it. So what it shows now here is that it is inside. This is left hand coordinate system. Here, next we will see point mass. You may think that point mass means a dot which has mass. It is not like that. So, point mass is nothing but an object which covers a very large distance compared with its size. An object which covers a very large distance compared with its size, I can call it as point mass. For example, let us consider a car. Now, it will be the starting player point is A. Now, the car covers a distance of 800 km and reaches at the B. Here, the distance covered is larger than the size of the car. That is called point mass. So, an object which covers a very large distance compared with its size, that is called as point mass. Understood? Next example, you can take Earth. Earth is considered as a point mass. Why, in a sense, if I see the Earth and the Sun, if I take Earth and the Sun, the distance between them is too large when compared with the size of the Earth. So, we can call the Earth as a point mass. Now you see, what is point mass? The mass of any object be assumed to be concentrated at a point. So, it is assumed to be concentrated at a point. Then we can call it as point mass. Why we need point mass? To explain the motion of the object, we need point mass. Mathematically, a point mass has finite mass with zero dimension. Finite mass with zero dimension. Next, we will see types of motion. There are 4 types of motion: linear motion, circular motion, rotational motion, and vibratory motion. So, what is linear motion? If an object moves in a straight line, then I can call it as linear motion. Example, an athlete running on a straight track. Next one, a particle falling. This is a earth, is a building. From here, if a particle is falling down towards the earth, then it moves in a straight line, so I can call it as linear motion. Next, we will go to circular motion. If the object moves in a circular path, I can call it as circular motion. Example, the whirling motion of a stone attached to a string. So now, is everything? A man is standing holding a string with a stone. So now if it rotates, this is called as circular motion. Then the motion of a satellite around the earth. Now this one is earth, this one is satellite. The motion of a satellite around the earth, we can call it as circular motion. Then we go for rotational motion. If an object moves in a rotational motion about an axis, it is important. About an axis, then it is called as rotational motion. Example, rotation of a disc about an axis to its center, spinning of the earth about its own axis. And last one is vibratory motion. It is to and fro motion. The to and fro motion, what we can call it as vibratory motion. Example, I can take simple pendulum. This simple pendulum will start moving to and fro motion. This is example for vibratory motion. The other examples are vibration of a string on a guitar, then movement of a spring. These are all 4 types of motion. So next we will see motion in 1 dimension, motion in 2 dimension, and motion in 3 dimension. Let us consider a particle has been moving and it can be expressed in terms of three coordinates: x coordinate, y coordinate and z coordinate. So it is not necessary that a particle should move in all the three coordinates. It may move in one coordinate, or it can move in with two coordinates, that is in the form of plane, or it may move in all the three coordinates. Now we will see motion in one dimension. It is otherwise called as rectilinear motion or linear motion. What is linear motion? If the object moves in a straight line, then I can call it as linear motion. Here in one dimension means it will move only in one coordinate. It may be x or y or z. It will move only in one coordinate, then it is called as motion in one dimension. Example, a train moves in a track in a straight line. Next, we will go to motion in two dimension. Now, this is x plane, y plane, y axis. This is a plane. In this plane, if the object moves, then I can call it as two dimension because of two axes. That is x, y. If the object moves in a curved path, then I can call it as motion in two dimension. Here it will represent what? Two planes. Sorry, it will represent two coordinates. So it means the position of the object changes with time. Example, carrom board. In carrom board, the points will move in two planes. That is in two coordinates. That is x coordinate and y coordinate. And get insect crawling on over the floor of a room. Next, we will go to motion in three dimension. In space, we take the particles will move in all the directions. That is in all the three coordinates. Then I can call it as motion in three dimension. If you take a bird, it will fly in space in all the directions. That is in all the three coordinates. Second example, gas molecules. It will move randomly in all the directions. Then kite during winter, that is windy day. During windy day, the kite will move in or will flies in all the directions. These are the three dimensions. That is motion in one dimension, motion in two dimension, and motion in three dimension. Thank you.